My name is Michal. I'm from the Faculty of Informatics of Masaryk University, and this is a presentation of our work on resources and future learners for in-context learning in Slavic languages for the Slavic NLP workshop at EACL 2023. In our work, or in this presentation, I'm going to introduce you to the basic terms of in-context learning. I'm going to show you the main objectives of our work, which is the overview of the data sets that can be used for the evaluation of in-context learning, the creation of the templates that we create to verbalize these data sets, the creation of the in-context learners that can be used for the unseen tasks predictions, and the evaluations of the existing models together with the new in-context learners that we create. We're gonna take a look at the results of this comparison, and we're gonna draw some conclusion from the evaluations. So in the task of in-context learning, the model is expected to make a prediction based on the input in the natural language. This input is expected to describe the tasks that we expect the model to perform with the input. Specifically, in the few-shot settings, we provide the model additionally with a set of demonstrations which assign the inputs to the expected outputs. In terms of the terminology, when we talk about the learning in context few-shot learning, we are talking about the prediction of the model. So we do not update the weights at this step, while during the training of the model, we update the model. So there is a distinction between these two terms. So our work aims to provide a basic infrastructure for the evaluation of the in-context learning in the Slavic languages. This infrastructure covers the overview of the data sets for the diverse tasks for the representative evaluation of the model, the curation of the templates that allows us to verbalize the inputs given in the data sets, the overview of the in-context learners, as well as the creation of some new in-context learners, and the assignment of the labels. So these are the main elements of the process. So concerning the current situation, currently we are not sure about whether the representative collection of the data sets, given the diversity of the tasks that are performed in natural language processing, can be found for all three of our languages of interest, which are currently Czech, Polish, and Russian. We do know that the previous work does not introduce any templates in our target languages that could be used. We do know that there are some in-context learners which theoretically support the languages of our interest, but we don't know about their quality, since they have never been evaluated in the interaction in our target languages, but only in English. So the overview of our work is shown here. We first survey the existing datasets. We collect the templates for the picked datasets of a representative set of tasks. We evaluate the in-context learners together with training some new in-context learners, and we finally assess the quality of the evaluation. So first, the survey of the datasets. We look for the datasets of the 4 task types. These are named entity recognition task, sequence classification task, question answering, and natural language inference. With some exceptions, we find the datasets for all of our target languages. However, we do not find any QA dataset for Polish, and the other compromise is that we also do not find the NLI datasets for Russian that would not be translated manually. Concerning the templates collection, so we manually collect 56 templates for our evaluation tasks, with at least 3 templates for each task. Our templates aim to simulate the interaction of the model with the native speaker of the languages of our interest. which is why both the input prompts and targets are in the target languages. So to reinforce the diversity, in the methodology of the collection of the templates, we first draw the template types from the larger collection of English templates, and we ask the annotators, which are the native speakers of our language, to transform these English templates to the most native form in their target language. Here are some examples of the templates, and let's look at the in-context learners. So we pose two research questions which address whether the existing in-context learner can also interact purely within our chosen non-English languages, since the evaluation before was always done only on the English instructions. And the second question is interested in whether the improvements in the large resource language are also relevant to the lower resource languages, in our case is the Slavic languages. If this shows to be true, then the improvements in the mainstream branch of the development of the in-context learning happening in English is also relevant to the other languages. So currently, the only model that supports, theoretically, our target languages is MTK Instruct, which has also been trained on 16 Polish datasets, 5 Russian datasets, and 2 Czech datasets, among a large mixture of 1,600 datasets of 55 languages. Since this is the only model, we also look at the axis of evaluation through the training strategy, and we take a look at whether the chain of thought reasoning pre-training displayed here from the original FLAN paper can also improve the models in the languages which the chain of thought has not been applied in. So we also train some new models. We synthesize the datasets for training this model from the existing question answering datasets. We follow the example of Min et al., which composes the meta-learning task from training the model to the explicit fusion learning patterns. So evaluation. We evaluate the existing fusion learners together with our new fusion learners using the consistent setting of the 3 examples, including the instructions for the model. We specifically look at some aspects concerning the training strategy, the mixture of languages, and the transferability of the in-context learning ability from the large resource source language to our target languages. So here are all our results segmented by the language. If we take a look first at the multilingual evaluations, we see that the models consistently perform better than the non-multilingual ones. When we take a look specifically at the model of the same kind performing in our languages, we see the consistent improvements up to a few exceptions. When we take a look at the training strategy impact, we see that the chain of thought reasoning also is able to improve the quality of the performance in the Czech interaction. However, we find some cases in which this approach completely fails, and we find that this is due to the fact that the model keeps predicting in English, even though the demonstrations that it has been shown are in Czech. So when we compare the performance of our trained models, we see that the incorporation of the English datasets into the fine-tuning help in all the cases, or in average, and the improvements are relatively big. When we take a look at also the improvements as compared to the previous models, then we can also see an interesting observation then that our models trained on a single task are competitive to the models which have been trained on 1,600 tasks. This is demonstrating the potential of multilingual fine-tuning specifically for the target language of our interest. So when we take a look at our research questions, we see that the existing in-context learners can perform quite well also in the non-English languages. However, this ability depends on a task. When we take a look at whether the improvement in the English can transfer to other languages, in case of the chain of thought, we see that this is true, and this is helping quite largely in some cases. However, the tuning to target languages still seem to help more. So the other takeaways here that you might be interested in is that the multilingual training helps in context learning in our target languages. The benefits of the improvement of the training strategies in the high resource languages are measurable. However, they are not consistent over all datasets. We find that the model size matters, that the larger models always perform better. We find that in-context learning ability can be also transferred cross-lingually, which is promising a great potential of application of the future development in in-context learning also in other languages. We find that in-context learners trained on a single task are also comparable to the multitask learners if they are specialized to our target language. So what can also be useful for you is the survey of the datasets that we provide, a set of the newly curated templates given by the native speakers of the languages, and the smaller in-context learners, which are the models specialized for Czech and Russian, which are by a magnitude smaller than the previous work, but performing comparably or even better. Thank you for your attention. And if you would have any questions, we are happy to answer your questions or take a look at the reference paper that we have here.